Hey math kids, today we're going to talk about domain and range, but before we get into that, we are going to talk about functional notation. Now you've probably seen, this is probably not the first time you've seen this, but it can really help us in our discussion with domain and range. Now in a general sense, domain represents all the x values, and range represents all the y values. Now over here there's no y written, but keep in mind that f of x is the same thing as y. And so this statement, f of x, can tell us a lot. So we know that f is the name. And so just like if we had g of x or h of x, g is the name of this function, h is the name of this function. Now notice that they all have an of x. That tells us what y is dependent on. So maybe you've learned in a previous class that x is the independent variable and y is the dependent variable. This notation is really nice because it tells us directly what our y value is dependent on. So y is dependent on x. So in other words, since x is independent, we think of x as just the thing that happens, naturally, or it's the most intuitive piece of it. And then y just happens based on whatever x already did. So it's just dependent on whatever x is telling us. Now I know that's kind of confusing how I said that, but when we come back up here, domain tells us our independent, and then range would be the dependent part of our function. Okay, so that's all kind of a general, general sense. That's what all that stuff means. Now let's get into some problems to see if they make more sense like that. So the first type of problems you're going to encounter are problems that just give you a graph, and you're asked to find the domain and range. Okay, so I'm just gonna do this. Domain. Now, there's a number of ways that we can write the domain, but I just want you to think of it in conceptual. Like, I'm not so worried about the notation right now. In this class, I think we're just going to use inequalities to describe different things. Now, notice that if we're only focusing on x values, so we're only looking from left to right, this function points down, but it also points to the left. And this function this side of the function points down, but it also points to the right. So that means we cover all the values all the way left, so we're all the way here at negative infinity, and then we cover everything to infinity, and we cover everything in between. So that means we cover all of the numbers. And so what we're going to write is we're just going to say x is contained on the set of all real numbers. So this is just the notation. It's kind of weird, but this just means everything. It means that we cover every single real number on the real number line. Now, if we're talking about range, we're going to talk about y values. Now, we don't cover all the values with y values because the highest value looks like it's about 2 right there, but we cover everything from 2 all the way down. And so the way that we're going to write that is we're going to say x is less than or equal to 2. So for example, if we pick a value for our y values or our range, if we pick x equals 5, and we go over to the graph, 1, 2, 3, 4, 5, is anything on this line contained on the graph? Well, the answer is no, because our parabola only goes up to 2, so it's only valid for, whoops, this isn't x, this is supposed to be y, sorry. It's only valid for y values less than or equal to 2. And I meant this to be a y also, sorry. That was confusing. So y equals 5 is what I meant to say. There's nothing on this line right here that's contained on our parabola, and so that's why this defines our range. Okay. Now if I picked a value like y equals -1, and I look right there and we go over here, if it touches the function even one time, then it's a part of our range. And so that is true. It actually touches twice. And that's within this range. And so that's why we define this function based on those values. Okay, let's try, we'll do another parabola. Alright, okay, so we have this. Once again, we look for the domain. So the domain goes all the way left, all the way right. There's no breaks or anything in between. And so we write this fancy notation. X is contained on a set of all real numbers. Now if we're looking at the range, it's going to be a y value. I don't want to mess that up again. But the lowest value right here is -2. And it's everything above that. So now we're going to say y is greater than or equal to -2. And that defines our domain and range. Now, this is the way we approach it when we're using models. So we collected data. Our data was discrete, meaning it was one value at a time, and they're not connected, they're not continuous. But then we created a continuous model. And so when we're doing a model like this, where it's a continuous function, where it's all connected, we can use this method. Now, sometimes, like in the real world, we collect data and it's disjoint, it's not connected, we call it discrete. And we're going to approach it a little bit different. So if we just collect a table of values, for example, maybe we have 1, 2, 5, 7, 3, 9, 6, 4. Okay, we collected that data. Don't know what that data means, but we'll just go with it. If we collect this data, we don't know what happens in between. We can't assume that there's a value at 1.5. We can't assume there's a value at 3 on this x, because we didn't collect that data point. So if we're talking about the domain, in this case, we're going to write it in set notation, and we just write all of our x values. So domain is x, once again, and so it's 1, 2, 5, 7. Okay, our range represents our y values. We write it in set notation, curly bracket, 3, 9, 6, 4. And these are the only values that are defined for y, and these are the only values that are defined for x. And so that's why we have to write it as a set instead of something that represents continuous points. So, once again, if we're just given a table, so we'll do it one more time. 1, 2, 3, 4, 5, 6, 7, 8. If I'm doing my domain, I write down my x values, 1, 2, 3, 4. If I'm doing my range, I write down my y values, 5, 6, 7, 8. Okay, that's pretty much it as far as that goes. Now, what we want, another concept we need to talk about is a practical domain. So sometimes, or actually, with your videos that you guys created, we created models. So we collected data points, right? We followed the path of the object that was thrown. Often the path is going to look like this because somebody was throwing it, so it starts a little bit higher and then it hits the ground, right? Now, with these models, though, we get these equations, and those equations go on forever. That's not very good. All right, let's try to connect this a little bit better. Oops. I don't know what's going on. This is weird. Okay. Okay. Let me try that one more time. I'm just trying to connect these dots. There we go. Okay, when we create a model, we get a continuous function that goes on forever. And for writing the domain, just the regular domain of this, we're going to get all real numbers. Now, just for simplicity, I'm going to say this is at 0, this one's at 1, this one's at 2, this one's at 3. This would be an object that was in the air for a very long time. 5, 6, 7, 8, 9, 10. So, dot, dot, dot. Okay. So if we do the domain of the dots themselves, like the actual data we collected, it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll put that in set brackets. So we list each value one at a time, like that. Now, with practical domain, we can change this red thing to only represent, so we change the model to only represent what happens in real life. So that's like considering it on the axes, like this. Now, even though the model supports this piece and the model supports this piece, those never happened in real life. The ball didn't come from infinity at the ground, go up, come through your hands, go make its path, and then continue through the ground as if there were no ground. Because of that, we can do something called practical domain. And the practical domain of this function, now if I'm using these numbers, which are a little ridiculous, but we would say that x is in between 0 and 10. Now you might look at that and you're like, okay, that seems pretty similar to what we wrote in white right here. It's not, though, because it's not only including 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but it's including everything that's in between those as well. And so it's like the orange portion right here, I'll draw it actually in green. This domain right here is representing only this piece of the curve. And that's called our practical domain because that is the domain that actually happened in real life. It's the practical part of our domain. And so on your assignment, there's going to be a couple questions that ask you about practical domain. Now, I just want to look at this in the context of our real, let me say this. I'm going to open this in Photoshop. Okay, so we had all this stuff happening. Now, if I ask you just for the domain of the model, I just want to know the domain of this piece. So to do that, you would graph this on Desmos and see what the domain is. Now, because it's a parabola, it's going to go all the way left, all the way right. And so just the regular domain of the model, so maybe I'll write it as is going to be all real numbers. Okay? Now, if I ask you for the domain of the data, and let's say I'm only going to ask you the first 10 pieces. For this graph, it's important to remember that our x-axis was the t, and our y-axis was the y. So the y is not confusing. But this x right here that we have in our data, remember, we didn't use this, so don't let it throw you off. Okay? Now, let's say I just ask you for the first 10 points found in your domain of your data. So the domain of your data. So you're just going to write down the first 10 points. So in this one, it's 0, and then 0.033, and then 0.066, and then 0.099. So that's 1, 2, 3, 4, and then 0.132, 0.165, 0.198, 0.231. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. 2 more. 0.264 and 0.297. Okay, so obviously the domain of your data is all of the points, but it feels a little tedious to write those out, especially when we already have a column, and this isn't even everything. I screenshotted it, but it goes down even further, right? So I'll probably just ask you on your homework just for like the first 10 points of your data or something like that, just so you can show me you understand the concept. Now, I'm also going to ask you about the practical domain of your model, because remember, this is the domain of the entire model of this equation, but our practical domain only goes from here to here. And so we can just see that from the graph pretty closely. So we go from 0 on here. I can't see all of my data right now, but if I had to guess, I would say that's like 1.6 or something. And so the way I would write it, so I'm going to say practical domain of the model, and that's going to go from 0 to 1.6. So 0 is less than or equal to x is less than or equal to 1.6. Okay? And that's mainly what we're going to focus on this. So if you need additional help, please come to MathLab. Until then, calculator.